Hi everyone, welcome back to our class about boundary layer. So today I would like to share with you about the formation of boundary layer and three important terms that you need to understand very well before we could solve problems in boundary layer. So boundary layer can be imagined like this. So what you need to know is actually we are discussing about boundary layer that occur on thin flat plate like this. So the formation can be described like this. Okay, let's say we have a uniform flow from left to your right here. So we could draw the uniform flow with the arrow like this and make sure that the arrow need to be the same because it shows that it is uniform flow and there are no resistance at this area. Once this uniform flow hit the thin plate here, no slip condition will occur. No slip condition means the molecule of fluid will stick very hard on this surface and the velocity of molecule at this region will become zero. However, because this fluid has its own fluidity, the molecule at this stage and so on and so forth, so will increase its speed gradually like this until at certain point the velocity at this point will same back to normal, which is the velocity at this region will be same with the velocity of the uniform flow here. Okay, at this point, so the phenomena is the same. The molecule of uniform flow here will have no slip condition. The velocity is zero here and we have velocity gradient occur like this. So the boundary layer is a layer from the no slip condition from the surface here to the local velocity that has 99% from the uniform flow. So boundary layer can be measured experimentally. So means that the boundary layer is actually a real phenomenon that can be captured by camera or can be conducted in laboratory works. Because of boundary layer here is the existing layer means that we could measure this one. We could measure its thickness. So in the next slide here, so this is also the formation of boundary layer. However, we could say that if the velocity inside the boundary layer here is flow in a certain pattern, so we could say that it is a laminar boundary layer. However, after a certain distance, we could say that velocity inside this boundary layer is become a turbulent. So at this moment, we could say that this boundary layer is turbulent boundary layer. Now, I would like to share with you three basic terms that you need to understand and you need to write its equation to solve boundary layer problems. The first one is boundary layer thickness. So it is written with a symbol of delta here. The definition of boundary layer thickness is a distance from the surface where the local velocity equals 99% of the free stream velocity u. So we discussed about this definition. A distance from the surface means a vertical distance from surface here to the point where the local velocity means velocity that occur inside the boundary layer. So means the local velocity, small u here, that equal 99% to the free stream velocity here, which is capital U. From that definition, we could say that boundary layer thickness can be expressed as delta is equal to Y, because boundary layer thickness is actually the thickness or the distance in y-axis. So its thickness means we are measuring from point A to point B. For the starting point here is 0 and the ending point here is a location where the local velocity, small u here, is equal 99% to the free stream velocity. The capital U here is the velocity of free stream velocity or the velocity at this area. Please subscribe this channel, C23 Classroom channel. Thank you for watching.